I'm Anna Martin-Riles, an assistant professor in ag and bioengineering here at UF. I grew up in southeastern California, near the southern end of the Sierra Nevada mountains, which is an interesting part of the world. On my side of the mountains is the Mojave Desert, a very remote part of the state, a very hot, dry climate. In fact, less than an hour where I grew up is one of the hottest places in the world, Death Valley. Maybe you've heard of it. But then just over the mountains to the west is California's Central Valley, one of the most productive agricultural regions in the world, and in fact the source of more than half of the United States' fruits, vegetables, and nuts. As a kid in school, we learned about California's diverse climates, as well as its history, and one topic that really impacted me was the construction of the Los Angeles Aqueduct. The LA Aqueduct was built in 1913. It was a major engineering feat at that time, and it was constructed to bring water that was produced by snowmelt in the Sierra Nevadas down to Los Angeles in order to support population growth and agricultural production. However, as a consequence of diverting water to LA, farming communities and natural ecosystems along the eastern Sierras were cut off from their water supply. This caused farming to pretty much stop in that area and resulted in significant irreversible changes to the natural ecosystems. It was this complex interconnection and tension between human systems and natural systems, as well as the impact that engineering solutions can have on the environment, that I found super fascinating. It seemed like there's this giant puzzle that we need to work out in terms of how we can best manage our limited natural resources, including water, energy, and land, in order to be able to meet the needs of society equitably and also preserve our natural environment and ecosystems, which are so important for maintaining the health and function of our planet. This led me to pursue agricultural and biological engineering as a major and profession. My research, as was mentioned, focuses on treating organic wastes like food waste, manure, even sewage sludge, to produce bio-based products like bioenergy and materials, and also recover water and nutrients. By recovering resources from waste, we hope to minimize the amount of natural resources we have to extract from the environment and reduce the amount of waste and pollution we put back into the environment. This kind of circular recycling of resources already exists in nature. Water, carbon, nutrients. The recycling of these elements is facilitated by various groups of organisms, including plants, animals, insects, microbes, etc., with the waste products of one organism serving as the energy and building blocks of another. Thus, we can look to nature as an example of how to optimize and recycle our natural resources. I'll leave you with one of my favorite quotes by naturalist John Muir, who said, "When we try to pick out anything by itself, we find it hitched to everything else in the universe." I think this is a good reminder that the world is complex and interconnected, and as we move through it, we should always consider the impacts that our choices and actions may have on others and our environment. Thank you.